While studying in SHSS, I noticed that many students there believe that they don't need maths because social sciences are independent from maths application. In order to prove my words, I took a survey, and here are the results. As you can see, 50 interviewers have economics major, which is somewhat related to maths. From the second graph, we see that only 40 students would take calculus if they had an opportunity to skip this class. From these two graphs, we can draw two conclusions. The first conclusion is that the majority of the students would not take calculus if they could avoid taking this class. And the second conclusion is that even not all economics major would take this simplest maths class in the university. As a maths major, I believe that maths took roots in every field of science, and even social ones are not exceptions. In order to prove my words, I will talk about definite integral and its application. Definite integral is defined as the area between the given curve above x-axis and two lines, x equal a and x equal b, so that we add the area that is above x-axis and subtract the one that is below. Definite integral is used in order to calculate Gini coefficient, which is also known as the measure of inequality. In order to calculate this coefficient, which shows the distribution of money among the population, we should use Lorentz curve. Stewart, in his book of calculus, defines Lorentz curve as the graph of function L of x on the interval from 0 to 1, so that every point on this curve has coordinates x over 100 and y over 100, so that x% of population receives only y% of total income. For example, here 40% of population receives only 12% of total income, and 80% of population receives only half of the total money. Now let's look at some basic Lorentz curves. As you see, the graph of the function y equal to x represents the egalitarian society, where everybody receives the same amount of money. The difference between y equal to x and Lorentz curve shows how this society varies from the equality. And in order to calculate Gini index, let's assign the area between Lorentz curve and y equal to x as a, the area between Lorentz curve and x-axis as b, and let's assign the Gini index itself as g. And now we have g is equal to a over a plus b. We know that a plus b is 1/2, because it is half the square with length of 1. Now we can rewrite the formula as g equal to 2a. From the second equation, we can subtract a, and we get g is equal to 1 minus 2b. But here comes a question: how to calculate b? And the way to calculate b started in calculus 1. b is the integral of Lorentz curve defined as Lx on the interval from 0 to 1. So that finally our formula becomes g is equal to 1 minus double integral of Lx starting from 0 to 1. And now I have the question for you. Suppose that our government decides to take a new economical policy. And actually, no one can predict whether this policy would benefit our society or whether it will fail us. How will we feel? Will not you be afraid?
Of course, probably will afraid.
Yes, so will I. And this is the situation when Gini index is used, because in political science and international relations, Gini index is one of the best ways to see whether the society becomes closer to egalitarian or totalitarian one, and whether the tax policy benefits the society or not. And the increase of Gini index shows that the society becomes closer to a totalitarian one, meaning that in society one person receives all the money. However, the decrease in Gini index shows that the society becomes closer to egalitarian one, where everybody gets the same amount of money, which is equality. And now let's look at some Gini indexes. Here you see 4 Gini indexes: before tax Gini and after tax Gini in the United Kingdom, the United States, Greece, and Italy. As you see, after tax Gini is less than before tax Gini in every of 4 graphs. And this means that these 4 countries held very, very good politics, which succeeded the people living in these countries. And to conclude, even though the majority of SHS students would skip taking calculus class, the application of this simplest maths class are widely used in both political science and international relations. And as we have seen, Gini index, which we've discussed today, is the good example of maths application in social sciences. Danica McKellar tells her students that maths is a tool that not only builds the foundation for a great career, but that also builds self-confidence, no matter what they choose in their lives. And I have nothing to add, because I truly share her opinion.